Welcome back. In this session, we are going to solve a problem involving determination of residue of a function at a specified pole of order 4. So to solve this, we start by finding all the poles of the function before now identifying the pole which has order 4. So first, i.e. solve the equation. Denominator is equals to 0. To find the poles of the function, you simply take the denominator and equate to 0. So that means z minus 1 power 4, z minus 2, z minus 3 equate to 0. And on solving this, we get z equals to 1, 1, 1, 1, z equals to 2, and z equals to 3. So there are 3 poles, but of these 3 poles, z equals to 2 and z equals to 3 are simple poles, while z equals to 1 is the pole of order 4. So actually that is what we need to concentrate on as per the problem. This pole of order 4. Now, f of z is given by z power 3 divided by z minus 1 power 4 into z minus 2, z minus 3. So let's call this one question 1. So since the pole of order 4 is z equals to 1, then we find the residue order 4 is 1, the residue by obtaining the coefficient of 1 over t, where this t, we take it to be this difference between z and the pole 1. So t equals to z minus 1 implies z alone is 1 plus t. So let's call this one equation 2. So replacing 2 in 1, we get, so where the z you replace by 1 plus t, and where the z minus 1 we put t. So we'll have f of, so z you put 1 plus t is given by z cubed. So z cubed is 1 plus t power 3 divided by, so z minus 1 power 4 will be t power 4, and then z minus 2 is the same as, so where the z we have 1 plus t minus 2, so this will be t minus 1. So t minus 1 and z minus 3 will be 1 plus t minus 3. So this will be t minus 2. So this now we have changed the structure of the value of f of z to be in the new variable t. So using binomial expansion, the numerator will be the same as t power 3 plus 3t squared plus 3t plus 1. We divide this by t power 4 into t minus 1 into t minus 2. Then we can write this expression on the right-hand side as t power 3 plus 3t squared plus 3t plus 1. You divide by t power 4, and then I multiply by 1 over t minus 1 times 1 over t minus 2. Note that when you simplify this, you still get back the original expression. Now, by doing this, the function 1 f of 1 plus t simplifies to, so divide every term here by t of power 4. So we have 1 over t plus 3 over t squared plus 3 over t power 3 plus 1 over t power 4. And then now this one, we can write it as 1 over, I factor out negative 1, and then I write the expression as 1 minus t. Note that this and these are the same, times, for this other case here, I'll write 1 over, then I factor out minus 2. So this will be 1 minus t over 2. Note that when you simplify this part, you should get back this other expression. And what is motivating us to do this is to ensure that we can write these two parts, this part and this part, as a series. So once we have that, negative 1 times negative 2 gives us positive 2, and this a half, so we can factor out a half, and we have f of 1 plus t equals to a half into 1 over t plus 3 over t squared plus 3 over t power 3 plus 1 over t power 4. And then this will be written as 1 minus t power negative 1. This other one will be 1 minus t over 2 power negative 1. So now when our expressions are of this form, it's very easy to find their series using binomial theorem, because we know that by binomial theorem, if you have an expression of the form 1 minus x raised power negative 1, then each series is 1 plus x squared plus x power 3 plus x power 4 plus other several terms plus x power n, etc. And this works when the absolute value of x is strictly less than 1. And you see, because the difference z minus 1 is assumed to be a very small positive number, then small positive number dividing by 2, you expect that to satisfy this condition, that expression of that value will be less than 1. These are very small numbers, so it's less than 1. So all these transformation, we were trying to ensure that we transform them in a form that will be easier to write them as series. So therefore, we'll have our f of 1 plus t to be a half into 1 over t plus 3 over t squared plus 3 over t power 3 plus 1 over t power 4. Now this will be 1 plus t squared plus t power 3 plus t power 4 plus other several terms. This other one will be 1 plus t over 2 plus t squared over 4 plus t power 3 over 8 plus t power 4 over 16 plus other several terms. So now the objective is now to expand these three brackets. Remember, this bracket has an infinite number of terms. This one also has an infinite number of terms. The only bracket that has finite terms is this first one. But because our interest is to find coefficients of 1 over t, then you don't have to be worried because those are the only terms that we're interested in. So because the highest power of the denominator for t here is 4, then to get 1 over t, then you expect that the numerator should have t power 3, so that when you have t power 4, you get t 1 over t. So we are going to get the product of these last two brackets, which have infinite number of terms, but only concentrate to those terms which will be giving us at most a power of t power 3. The rest will not actually matter because they will not give us the coefficient of 1 over t. So the next step, we write f of 1 plus t will be a half into 1 over t plus 3 over t squared plus 3 over t cubed plus 1 over t power 4 into, so we're going to get the product here, but only interested with the terms that so 1 plus t, so 1 by this other term will give us t squared over 4, and then plus 1 times this term will give us t power 3 plus 8. I don't have to include this 1 times t power 4 over 16 because it will not help me to get 1 over t. So just stop there for 1 times this second bracket. Plus, then I go to 2, to this t. T times 1 is t. T times this other term will be t squared over 2. And then t by this will be t power 3 over 4. I don't have to go up to this one because a power of t power 4 will not help me to get 1 over t. And then t cubed times this will give me t power 3. T cubed by this one will give me t power 4 over 2, which will not help me, so I don't have to include that. And then plus other several terms. Then I close. So then I'll have f of 1 plus t would be a half into, now 1 over t plus 3 t squared plus 3 t power 3 plus 1 over t power 4. Now these are the brackets, so yes, I have 1. So t over 2 and t are like terms, so when I put together I get 3 over 2t. Those for squares, I'll have a quarter plus a half. So that will give me 3 over And then, so this will be 1/4. So I have 1/4 and then plus t²/2 and then plus. So remember there's also 1 by up to this point. So I have this term. So t by this is t by this is t²/2, t by this term will be t³/4. And then next term, so before I close brackets here, then I should have, so I've interpreted this 1 by this bracket, t by this. So then next one I need t² times 1, I get t², and then t² times this will be t⁻3/2. And then so I don't have to include the next one because it gives me power more than t⁻3 plus t⁻3 by this, I get t⁻3. And then that's where I need to stop. So then those for power 2 will have this term, and then this term here. So I'll have 1/4 plus 1/2 plus 1. That will give me 7/4 t². Those for power 3, I'll have 1/8 plus 1/4 plus 1/2, and then plus this one. That will give me 15/8 t⁻3, and then plus other several terms. Remember I said that these two brackets, this bracket and this bracket, have an infinite number of terms, but because our interest is to find coefficients of 1/t, and the highest power of denominator here is 4, so 1/t⁻4. So what gives me 1/t is when I multiply t⁻3 by 1/t⁻4. So when I'm expanding these brackets, I just ensure that the highest term in the expansion the expansion of the product is t⁻3. That will give me my desired answer. So things which are more than powers of t which are more than 3 are actually not going to help us to find the solution. So that's why we are actually only writing this number of terms in our product of these two infinite series. So once we have this, now we'll have f of 1 plus t will be 1/2 into. Now let's see the coefficients. What will give us as coefficients of 1 of t is what matters. And then these other terms, we don't have to take care of them. So if I have 1/t, I need to multiply by 1 to get a coefficient of 1/t. So then 1/t times the rest of the terms in this series doesn't matter. Next one, if I have a t² here, then I need the term with t, so that t times 1/t², I get 1/t. So this term times this term, I get 3/3 is 9, and then over 2, plus this term here, I need highest power in the numerator to be t². So I'll have to multiply this term and this term here to get coefficient of 1/t. So 3/7 is 21. 1/4 is 4. So that'd be the coefficient. And this other one, I need to multiply by this term to get 1/t. So this will be 15/8. The rest of the terms, we don't care about them because they not give us coefficients of 1/t. Now, when you add this, you get a half times the sum of this is 101/8, and then 1/t plus other several terms. So this is f of 1 plus t. So f of 1/1 plus t is 101/16, 1/t plus other several terms. So since the coefficient, i.e. the coefficient of 1/t is 101/16, therefore the residue of f of z that was given by z cubed divided by z minus 1 power 4, z minus 2, z minus 3, at a pole of order 4, which is actually z equals to 1, is this coefficient of 1/t, which is 101/16. So this is the solution. Thank you.